Hello everyone. We are discussing about our chapter motion in a straight line. Motion in a straight line. Motion in a straight line. Previous we are applicable to some of graphical methods. We are applicable to the constant one. Again uniform method. Again we are starting to the constant and uniform method. Slowly, okay. Right, we are going to applicable some of speed and velocities. How we can manage, okay. Right, today we are discussing about average speed and instantaneous speed. Okay, average speed and instantaneous velocity. Average speed and instantaneous velocity. Our average distance and average displacement we are also introducing. Okay, right? We are going to average speed and instantaneous velocities. The most one we are taking. Speed, the position of the properties. Velocities, the position of the properties also we are taking. Right? Now what is the speed and what is the velocity? First we are going to, now we are going to average speed and instantaneous speed. Okay? Right? We are going to average speed. Speed means our previous application or our previous equation, speed is equals to path length by time period. Path length by time period. This is the speed of value. Okay. Now velocity is equals to displacement by time period. Displacement by time period. Okay. Now speed is equals to path length by time period. Now velocity is equal to displacement by time period. Now we are getting to path length is equals to main we are taking distance. Which one? Distance. Now distance means when an object moving, some of actual path of the position is known as distance. Now displacement we are going to the shortest distance between any two oblique points. The first point A and second point B oblique points. Okay, clearly we are going to applicable. The rate of change of displacement is known as velocity. Okay, the time period which it managed to path length. Okay, now we are going to average speed and instantaneous velocity. Okay, now we are applicable to some of aerial configurations in this part. Okay, now average speed means average speed. Now definition of average speed. Okay, measure of total distance covered in a given time. Okay, measure of total distance covered in a given time. Now this one is average speed, right? We are going to measure of total distance covered in a given time. Now this is the definition of average speed. Okay, right? Again when we are choosing instantaneous velocity or average speed or average velocity, how we can manage it? Okay, now average speed and instantaneous velocity. Now we are going to instantaneous velocity or instantaneous speed also we are giving. Okay, measure of distance covered in instant time period. Now this is the definition of instantaneous velocity. Now instant time, the manage of instant time we are giving to instantaneous velocity. Now we are previously are going to average speed and average speed. So average displacement and average speed we are getting to some of we are applicable to the displacement of the properties is known as the instantaneous velocity. Okay, right? We are going to the sum of statements is here. The first statement and second statement. How we can applicable to the statements of the PRTs. Okay, right? We are going to the applicable of the method. Right? For example, A is the object one. position of B is the object. A is the object position or the B is the object position. Right? This is the distance of the displacement property at A to B. Right? The distance of A to B they are applicable. The distance of A to B. Now average speed we are applicable. Okay, average speed. Right? Now we are applicable to the sum of statements of the here. Okay, DAB. Okay, this is the, for example, 1 kilometer. This is the 1 hour. 1 kilometer and 1 hour. The distance of A to B we are applicable is equals to the total distance. Okay, the total distance covered by total time period. Right, we are going to 1 by 1 is equals to 1 kmph. kmph. This is the first one. Again, we are choosing to the same one. Let B to C. For example, again object we are applicable. Let B is one. Now C is one. Okay. The distance between B to C we are going to 2 kilometers and 2 hours. 2 kilometers and 2 hours. The distance of at B to C is equals to, the distance of at B to C is equals to, same we are applicable the distance by time period also. Previously we are applicable path length by time period. Again we are choosing to the distance by time period. Okay. Now we are going to 2 kilometers by 2 hours. 2 ones are 2 twos. We are getting to 1 kilometer per hour. 1 kilometer per hour. Again we are choosing to the same displacement manner also or distance manner also. For example, this is the C1 object. This is the C. No. Okay. The distance we are managing. Okay. This is the 3 kilometers of the distance we are applicable. Right. Now this is the 2 hours of the time period. We are changing 1 and 1, 2 to 2 at the same time. 3 to 2 applicable. Right, we are applicable to the sum of the displacement properties here or distance properties as here. Okay, right, the distance of C to D, the distance of C to D is equals to distance by time period. Now distance we have taken 3 by 2. Now 3 by 2 is equals to 1.5 kmph. Now this is the inferior property. Okay. Now we are applicable the net distance of the time period and displacement of the time period. Displacement of the time period. Displacement of the time period. Okay, right? We are going to the net means the total amount of energy. Total amount of average speed. The total amount of average speed. Now the total amount of average speed is equals to, we are going to V is equals to V1 plus V2 plus V3 by the time period T1 plus T2 plus T3 time. Okay, right? We are applicable to the first one and second one, and this is the third one. Okay, the moreover, first we are going to the velocities that we are going to the velocities, how we can manage. Okay, right? The velocity V is equals to first one 1 plus 2 plus 3 by 1 plus 2 plus 2. So this one 6 by 5. Okay. Right, the management is 1.22. Okay, now the speed is 1.2 km per hour. 1. Now this is the statement of a property. Okay, so average speed and instantaneous velocity. Now average speed we are getting to at A to B. Okay, at B to C, at C to D, at D. Okay, right, the overall net means we are applicable the total amount of average speed is equals to, and V is equals to V1 plus V2 plus V3 by T1 plus T2 plus T3. So this is the average portion of the numerical system. Okay, and we are going to the graph property of distance and time period graph. distance and time period graph. Okay. The graph of distance and time period. Time period. Okay. Now distance. Okay. First we are going to the graph position. Sometimes we are applicable at A to B distance 1 kilometer 1 hour. At B to C the distance 2 kilometers 2 hours. Okay. Now next C to D the distance 3 kilometers and 2 hours in previous one. Okay. The graph situation will be applicable. Now we are going to the distance of AB, the distance of BC, the distance of C. Okay. Right. The graph portion. This is the graph portion. Okay. This is the origin point 0. Okay. 1, 2, 3, 4, 5, 6. Okay. The next one, this one. 1, 2, 3, 4, 5. Again 6. Okay. The distance of A to B. First we are going to at 1 out of 1. Okay. 1 kilometer per 1 hour. Okay. But this is the property. 1 kilometer per 1 hour. Now x-axis is always we are going to time period. We are going to always time period. Okay. Now y-axis we are going to always distance. Distance. Okay. Now distance. So distance we are applicable. The distance one again time period. Okay. This is the direction of the property. Now this is the direction of the property. Okay. At 0 to 1. This is the first statement. Now, first statement. This is the theta 1. Okay, at distance to AB 1 kilometer and 1 hour. Okay, again we are choosing 2 kilometer per 2 hour. Okay, 2 kilometers distance and 1 to 2 kilometers at the same time. This one also we are choosing. Okay, write 2 kilometers. Okay, 1, 2, 1. Okay. Now this one. This is the theta 2. Okay. Now, at distance of C to D at 3 kilometers and 2 hours. Okay. 2 hours time period. This one. Okay. This is one. 3 kilometers. 1, 2, 3. Okay, this one. Yes, this one. And here, now this is the portion 2 kilometers. 2 kilometers. The man in the to 5, fifth portion. Now this is the theta 3. The distance of A to B, the distance of B to C, the distance of C. Now this is the previous position. We are applicable that the distance of A to B is equals to 1 kilometer of distance and 1 hour of time period. Okay, the distance, the time period. Okay, the distance of B to C, 2 kilometers of distance and 2 hours of time period. 2 kilometers of distance and 2 hours of time period. Now the distance of at C to D is equals to 3 kilometers of distance and 2 hours of time period. 0 to 1 kilometer and 1 hour time period. 2 kilometers, 2 hour time period. 3 kilometers, 2 hours time period. Now this is the graphical method. Now graphical method we are applicable to some statements how we can manage. Now note this. Okay. Now next one, average and instantaneous velocity. Now previously we gave average and instantaneous speed. Now this one is average and instantaneous velocity. Now what is the difference one? Now how we can manage? Okay, right? We are going to average and instantaneous velocity. The same also average velocity. Okay. Now average velocity and instantaneous velocity. Here we are applicable average and instantaneous speed. Now previous one, average speed and instantaneous speed. Now this is the previous one. Now this one, average velocity and instantaneous velocity. Okay. Now average velocity. Now what is the definition of average velocity? Okay. Clearly we are explaining average speed, average velocity, average velocity. Now what is the definition of average velocity? Okay. To measure of total displacement, the total displacement covered in given time period. To measure of total displacement covered in given time. Our previous one, average speed, to measure of total distance covered in given time. Now this is the displacement, previous one distance. Previous one distance, displacement. Distance means we are applicable speed. Displacement means we are applicable velocity. Clear? Now this is the vector quantity. That one should scalar quantity. Right? Average velocity is equals to measure of total displacement covered in given time period. Okay. Now this is the average velocity. Now we are going to instantaneous velocity. Instantaneous velocity. To measure of displacement covered in instant time. Which time? Instant time. Clear? Our previous one we are expected instantaneous speed is equals to our instantaneous speed definition to measure of distance covered in instant time period. Now this is the distance. Okay, distance one we are applicable instantaneous speed. Speed means distance. Always we are remembering the speed recognized is always distance property. Okay. Now velocity we are applicable displacement property. Clear? The first one, speed which covers distance property, velocity which covers displacement property. Now average velocity means to measure of total displacement covered in given time. Instantaneous velocity to measure of displacement covered in instant time. Instant means we are applicable. Some we are applicable to the smallest one, the shortest objects or shortest places. When we are applicable, the shortest displacement between any two objects. Okay, now this is the velocity. The rate of change of displacement is known as velocity. Clear? The shortest one we are applicable instant one. Okay, the total time period, total displacement is applicable in average. Clear? Now this is the one. Now fundamentals of some of the example we are taking. Now what is the example? How it managed? Okay. Now example. For example, at A to B, the positions of A to B and positions of B to C and positions of C to D in your previous application. Okay. Now for example, when we are choosing one of the object A, again I am choosing that at B position. Okay. The distance, the displacement between A to B at 1 kilometer and 1 hour. Right? Now this is a very important one. Average velocity and instantaneous velocity. Now for example, we are choosing any two positions of object. The first position A and second position is B. Okay, now this is the same way we are applicable. 1 kilometer of the displacement, 1 hour of the time period. Okay, now the displacement of A to B, the displacement of A to B, or the x displacement of A to B. This one also we are taking, if anyone we are using. Okay, right? We are going to the displacement of A to B is equals to 1 kilometer of displacement and 1 hour of time period. 1 kilometer of displacement and 1 hour of time period. Okay, again we are applicable to the same position of same manner, right? Now this is the object position B. Again I am choosing second one C. The displacement between any two objects or any two positions, initial position to final position. Okay, right? Initial to final we are going to 2 kilometers and 2 hours of time. The first one, our previous also we can same one. Today we are discussing about average and instantaneous. Previous one speed, this one velocity. Okay, right? At B to C, the distance of or displacement of at B to C or R x of BC also. X means the displacement coefficient. Okay, B means the position of initial one, C means the final one. Okay, right? We are applicable to at x of at distance of or displacement of at B to C is equals to 2 kilometer of displacement and 2 hours of time. Okay, 2 kilometers and 2 hours. Now again we are choosing at C, at D of object. The displacement will manage at 3 kilometers and 2 hours. 3 kilometers and 2 hours. 3 kilometers of displacement, 2 hours of time period. Okay, the displacement of distance we are taken at C to D is equals to 3 kilometers of displacement and 2 hours of time. Now this is the pattern position. Okay, now we can applicable to the sum of pattern position. Okay, right? We can applicable to some node point is here. The overall velocity v is always not is equals to v1 plus v2 plus v3. Now very important. Okay, the total velocity is not is equals to the sum of adding of velocities. Okay, now this is a very important part. The discussing about the topic is the total or average velocity is equals to average velocity means the total displacement covered given with the time period. The total means the distance of AB plus the distance of BC, the distance of C. Now this is the priority. Okay, the total given the time period T1 plus T2 plus T3 time period also. Okay, this is the one. Okay, from the distance of AB is always applicable 1 kilometer and 1 hour representation. Okay, the displacement by time period. Okay, now displacement how much? 1 by 1 is equals to 1 kmph, kilometer per hour. This is the first one. Okay, the distance of at BC, is equals to 2 kilometers and 2 hours of journey. 2 kilometers and 2 hours of journey is equals to displacement by time period also always time period is equals to at 2 kilometers by 2 hours. Again we are choosing 1 kilometer per hour. Again the same one, the distance of at third quantity at C to D. We are applicable the distance of at C to D or displacement of C to D is equals to displacement by time period. Now displacement we are applicable how much? 3 kilometers and 2 hours. Okay, at 3 kilometers by 2 hours is equals to 1.5 kilometer per hour. This is the position of velocity. Now velocity 1, velocity 2 and velocity is 3. There are 3 types of velocities here. Okay, this is the total position of the velocities. And we are taking the positions we are applicable to sum of at A to B, B to C, C to D. Okay, there are those positions we are applicable to same one. For example, the position of A, the position of A, the position of B, the position of B, the position of C position, the position of D position. When an object moves towards A to B, the direction of the position, direction means we are applicable sum of vector quantity. Vector quantity means we are applicable velocity, right? We are going to. The symbol is always indicating to the vector quantity, the direction of the symbol, right? At A to B is the position factor. Now we are going to, when an object moves towards A to B, again the object moves towards B to C, C to D. There are 3 positions, A to B, first one, B to C, second one, C to D, third one. Now this is the priority of the position of the graphical analyzer. Okay, right? We are going to the graphical analyzer. Now what is the difference one and what is the previous two? Average one. Okay, right? We are going to graphical representation of average velocity and instantaneous velocity, or position and time graph. Okay, right? Graphical analyzer of average velocity and instantaneous velocity. Okay, by using of position and time period graph, by using of position and time graph. Position and time graph. The first we are going to, this is a very important one in your option purpose. Okay, right? When an object, for example, A is the position of object. There are positions is here. This is the first position A. This is the second position of B, and third position of C, and fourth position of D. There are 4 main positions. The first one we are taken, the displacement or distance. So it is again same what we are taken. Displacements also we are taking giving to the D, at D of AB, at D of BC, at D of C. There are 3 positions. The positions will be at A to D. We are going to the displacement when an object moves towards 8th position to Bth position. Which position? 8th position to Bth position. Okay. Right. Same one we are applicable 1 kilometer and 1 hour time period. Now we are going to 1 kilometer and 1 hour time period. Right. Again at B to C. 2 kilometers and 2 hours of journey. 2 kilometers and 2 hours of journey. Okay, this is the representation one. At B to C, when an object moves towards A to B, along B, okay, B to C along with 2 kilometers of displacement, 2 hours of journey. Right, again at C to D. Okay, along at C, along D. Okay, the positions we are taken 3 kilometers and 2 hours of journey. 3 kilometers and 2 hours of journey. The motion will be applicable. There are very important one. A is the position factor. B also position factor. C also position factor. D also position factor. Okay. Now axial fundamentals we are going to applicable. This is the axis purpose. Always which is going to x direction. Which direction? X direction. Now this is the always equilibrium position or equal position or y axis position. Okay. This is the axial position. This is the equatorial position or y axis position and a y direction position. Okay. Now this is the minus x direction position. Which position? There are three positions here. The first one, the distance of A to B, 1 kilometer and 1 hour distance, 1 hour time period. And 2 kilometers of displacement to 2 hours of time period. 3 kilometers of displacement, 2 hours of time period. Okay. There are 4 different positions and 3 characterizations. The first one, this is the spatial first one, second one, again third one. This is the forward direction, positive direction, positive x direction. Now this is the positive y direction. This is the negative x direction, negative x direction. Now we are applicable to same horizontal one, vertical one. We are applicable to again we are choosing to the negative one. Okay, right? We are going to the graph analyzer. Okay. This one is along x axis or x direction. Which direction? Along x direction. Okay. Now this one is along y direction. Which direction? Along y direction. The same one we are applicable. So this is the one. This is the graphical analyzer. This is the x-axis, y-axis, x-axis, y-axis. Now x-axis which we are applicable always time period. Which one? Time period. Okay. Now this one is always position. Position means displacement. Previous we are applicable. This one is position 1. Now this one is time period 1. Right? Yes, this one. Okay. Now this is the origin point. Okay. Sum of coordinates were applicable. Now this is the graphical analyzer. This is the 1, 2, 3, 4, 5. Okay. Enough. Now this one also. 1, 2, 3, 4, 5, 6 for example. Same one. This one also we are giving 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, again 5. Okay. Here we are observing it along x direction, it along y direction. It along x direction, it along y direction. This is the x direction property. This is the x direction property. This is the y direction property. Okay. At velocity of vx is equals to velocity of x direction. Which one? Velocity of x direction. This is the x direction property. Now it's the velocity of y direction property. Initially we are taking x direction is a very important one. We are choosing how much we are taking. Okay, right? X direction. X direction we are getting 1 kilometer and 1 hour. 1 kilometer and 1 hour. Okay. Now 1 kilometer we are applicable. This is the constant one. Okay, constant one. So 1 kilometer. This is the 1 kilometer point. For example. Okay, but this is the 1 kilometer point. Clear? 1 kilometer one. We are applicable tan theta is equals to y by x PRT and 1 by 1 is equals to 1 kilometer per hour. This is the first one. Vx. Okay? Vx property. Now we have y direction. This is the y direction property. Now y direction we are applicable at 2 kilometers and 2 hours. The journey we can applicable to the first one. X direction we are applicable to 1 kilometer. This is the 0th application. 0 to first one. 0. Okay? And 0 to position. Clear? And Vy is equals to 0. The velocity of that y direction property. Clear? This is the initial energy position. Now we are going to second one. And x direction, along x direction, we are applicable the displacement property at B to C, 2 kilometers and 2 hours. And along the y axis process. Okay, 2 kilometers Okay, right one we are going to X process, we are applicable to sum of statements. So this is the property. This is the constant property. 1 to 2 kilometers, 2 kilometers we are applicable. Okay, now Vx is equals to the constant one, Vx is equals to 0 3 and y direction we are applicable at 2 kilometers are, okay, 2 kilometers and 2 hours. At 2 kilometers means we are applicable, so this is the 2 kilometers of the property. This one. Now clear? So this is the expression. Now this is the theta 2. Now again we are choosing to the third one. Now y is equals to, okay, now tan theta is equals to y by x. Previous one, along with the straight line equation, y is equals to mx plus c. C means the critical, the position which will be, we are intersecting position, c is equals to 0, our previous class. Today we are discussing about the class means the tan theta is equals to y by x. Now y means we are taken the positions we are applicable. We are positions that are applicable at 2 kilometers by 3 minus 1. 3 minus 1. Okay. Now 2 kilometers by 2 hours. 2 ones are 1 kilometer per hour. Okay. Along with the third one, the distance we are applicable 3 kilometers and 2 hours. Along with the negative direction, negative x direction. Okay, negative x direction. Right? We are going to negative x direction. Okay, right? This is the minus 1. This is the minus 2. Minus 1 and minus 1. At any third 3 kilometers. 3 kilometers means we are applicable. This is the 3 kilometers. Same one. So this is the position of 3 kilometers. Okay, 3 kilometers. Now say along with y-axis means we are taken to initial the end of the position, 0 position. 2 kilometers. So this is the end position. End position. Clearly we are observing at Vx is equals to tan theta is equals to y by x. Tan theta is equals to y by x. This is the first one. This is the second one. And this is the third one. Vx is equals to tan theta is equals to y by x. We are applicable. How much we are giving? Your 3 kilometers. Right. If we are taken, how much? 1/5 one. The fifth position. The 5 minus the 3 kilometers. 1, 2, and 3. 3 after 3. Okay. Right. 3 by 2. 2 ones are 2 1.5. Okay, this is the Vx. Now Vy is equal to the position which will be 0th position. This is the position. Vy is equals to 0. This is the ideal configuration at Vy is equals to 0. The position which can be always the velocity V is equals to, or V is not is equals to V1 plus V2 plus V3. This is the very important. Right, we are applicable to some, again I will explain. Okay, by using of position and time period graph. The position means we are applicable, always it can be displacement property. Now displacement means we are applicable. Okay, for example, the position of A, the position of B, the position of C, again position of B. There are 4 types of positions. Now first position A, at A to B, 1 kilometer and 1 hour, 2 kilometers and 2 hours, 3 kilometers and 2 hours. On our previous one, same one. Okay, let the position will be managed to displacement of A to B, displacement of B to C, displacement of C to D. There are 3 types of displacement. The first position of first position, second position, third position. This is the positive x direction, positive y direction, negative x direction. There are 3 inferior positions. Okay, the positions will made by A to B is equals to, this is the positions. Right? Along with x axis, along with y axis. How we can applicable to differentiation of x axis and y axis? Now we are applicable x axis, the position, y axis. Okay? For example, this is the home, this is the shop, this is the college, and this is the playground. Home, shop, this one college, and this is the position playground. There are 4 positions. I have started home to shop. Okay, this is the 1 kilometer and 1 hour. Shop to college, 2 kilometers and 2 hours. College to playground, this is the 3 kilometers and 2 hours. Yeah. Okay, this is the positions. Now we are applying A, B, C, D. Okay, right, going to home, shop, college and playground. There are 4 situations. Okay, 3 statements now. Okay, they are applicable. This is the x-axis, y-axis along with the negative x-axis. Right, along with the x-axis or x direction, we are applicable. And to position, at 0 to 1 position, we are applicable. 1 kilometer of journey, 1 hour of time period. 1 kilometer of journey, 1 hour of time period. Okay, right, and secondary statements, at y is equals to 2 kilometers and 2 hours of journey. Okay, this is the 0th position. 2 kilometers of the position. At 1, 2 kilometers of position. At 1 to 2 hours of journey. This is one. Again, we are choosing and 3 kilometers and 2 hours of journey. 3 kilometers means we are able. Okay, so this is the starting position. 1 kilometer of the position. 1 of 1. 1, 2. Again 3. There is 3 positions is here. Okay, right? 1 kilometer and 2 kilometers and 3 kilometers. Every kilometer will be important to the position. Okay, along with x-axis, along with the y-axis. Okay, now this is the positions. At v is equals to always v1 plus v2 plus v3. Now this is the positions will be applicable to graphical analyzer of average velocity and instantaneous velocity with respect to by using position and time graph. The position means is always displacement. Okay, this is the displacement property. Okay, time management will be applicable to the graphical analyzer. Now this is the 2 graphs very important for option purpose. Okay, not your IP, option purpose. Okay, Vx is the x coordinate position is always tan theta. By representing our previous class by using straight line equation, y is equals to mx plus c. C is the position of intersecting position. We are not applicable any intersect position. C is equals to 0, y is equals to mx, then m is equals to y by x. This is the m is the magnitude which we are applicable tan theta. This is the equation of tan theta is equals to y by x. Okay, now 1 by 1 is equals to 1 kilometer. Okay, 2 by 2 is equals to 2 kilometer. Again we are using 3 by 2 is equals to 1.5 kilometers. Okay, this is our class.